Hello, this is Ms. DB, and today we're going to talk about Chapter 7, Section 4 on applying properties of similar triangles. So we are going to use the properties of similar triangles to find segment lengths and apply proportionality and triangle angle bisector theorems. We're going to be pulling together what we've been learning about this chapter as well as some things like angle bisectors. Our vocabulary, well, maybe there is no vocabulary. That's usually on this slide, but it seems to be missing. All right, artists use mathematical techniques to make two-dimensional paintings appear three-dimensional. The invention of perspective was based on the observation that faraway objects look smaller and closer objects look larger. There's theorems, mathematical theorems like the triangle proportionality theorem are important in making perspective drawings. So this is the triangle proportionality theorem. It says that if a line is parallel to a side of a triangle and it intersects the other two sides, then it divides those sides proportionally. So here's a triangle ABC, and then line EF went through the triangle, and parallel, that's what those little red arrows mean, parallel to side BC, so EF is parallel to BC, then what happens is that this little segment here, AE over EB, is equal to AF over FC. And we can use that to find missing parts. All right, so let's see how that's going to work. We are going to try to find US, which is this little section right here. We know that RU is 14, we know that RV is 10, we know that VT is 4, and we're looking for US. We also know that this line, UV, is parallel to ST. They're marked parallel. So therefore, we can set up a proportion using the triangle proportionality theorem, and we are going to plug in our missing parts. So we can say that US over 14 is equal to 4 over 10. And then we just solve that little proportion using cross products. So it's a pretty easy problem, but you really have to make sure that you set up the proportion correctly. Like if you had said 14 over US equals 4 over 10, you'd get the wrong answer. So we get the answer of 5.6 or 5 3/5. Okay, here's the same type of problem. This time we're looking for PN right here. You can call that X if you want. So we know that 3 over that will equal 2 over 5. Or you can say X over 3 equals 5 over 2. You just have to make sure you set it up in the correct order. So we can say 3 over X, or 3 over the length of PN, is equal to 2 over 5. And then that's the same as 15 equals 2 times the missing number. So 7.5, or 7.5. All right, there's a converse of this is also true. If these are proportional, the sides are proportional, then this is a parallel line. So the converse is true as well. So if they ask us to figure out if the lines are parallel or to verify that they're parallel, we're going to set up a proportion and see if it's true. So our proportion would be 8 over 12 equals 10 over 15. And because, and you can do it 8 over 12 equals question mark 10 over 15. If these two things are equal, then we have a true proportion. So you can check this by seeing if the cross products are true. Is 8 times 15 equal to 10 times 12? Or you can do what they did. You can simplify each ratio and see if you get the same number. So in this case, 10 over 15 equals 2/3. 8 over 12 also equals 2/3. So therefore, these two lines are parallel. Or you could say 8 times 15, that's 120. 10 times 12 is 120. So because the cross products are true, it's a true proportion, and therefore the lines are parallel. Two different ways to go about that. Okay, let's check and see if this one has two parallel lines. They don't tell us what AD is, but they do say that from here to here is 36. And they say that from, let's see, where's BC? B to C is 27. So the theorem says that these segments are proportional. So we need to figure out, let's see, if this whole thing is 36, 36 minus 20 is 16. And if this whole thing is 27, 27 minus 15 is 12. So they did DC is 20. And I don't know why they set it up this way. Oh, I see what they did. They did DC over AD. So 20 over 16 equals 15 over 12. So they have to check and see if 15 over 12 is also the same. And again, you could also say 16 over 20, does that equal 12 over 15? And if you get a true proportion, if this works, then you could say that the lines are parallel. Since they simplified each ratio to the same thing, then you would say yes, AB is parallel to DE. Parallel on your keyboard, there is on my keyboard, it's right below the backspace and right above the enter, there's a straight line. And I would have to use shift and then that straight line. It's like where the backslash is. So I could use 2 of those in a row to mean parallel. Or you could use 2 of the forward slash 2. That would work. All right, there's another theorem here. It's a corollary to the other one. Sorry. If 3 or more parallel lines intersect 2 transversals, then they divide the transversals proportionally. So it doesn't just have to be triangles, it can just be parallel lines. So here we've got 3 lines, parallel lines. These lines are all parallel. And then there's 2 transversals going through them. So AC over CE is equal to BD over DF. And if there was another parallel line, you could set up more proportions. So here's an example of a perspective drawing. The farther away from the viewer, from your point of view, which would be like right here, the smaller those trees are going to be. And it says that in the figure, if AB is 4.5, BC is 2.6, CD is 4.1, KL is 4.9, they want you to find LM and MN, both of these parts. So we can look at this in two different problems. So we could just look at this section from here to here, and we could say, well, that means that 4.5 over 2.6 will be equal to 4.9 over question mark over LM, the length of LM. And we'd solve that for LM. Once we know LM, then we could look at this part from here to here. And we could say 2.6 over 4.1 will be equal to what we got for LM, and we'll plug it in there, over MN. So we'd have to find LM first, then we could plug it in and find MN. So let's see what they got for this. So we know that those lines are parallel. That was told to us. We're going to use that corollary to set up our proportions and find LM. And when they did that, use the cross products, they found LM is equal to 2.8. So now we know that this here is 2.8. And now we can use the 2.8 and plug that in. So they're doing theirs a little bit different. They're not using what we just found. They're saying I can do this and this. They're like jumping over the middle part, which also will be true. And then that way, the advantage of that is that you're not using a number that you calculated, just in case you had calculated it wrong. And then they got an answer of 4.5 inches. All right, so the triangle angle bisector theorem brings us to this theorem. That's this theorem. An angle bisector of a triangle, remember angle bisector divides the angle into two congruent angles, divides the opposite side into two segments whose lengths are proportional to the lengths of the sides. So in this one, BD, this piece down here, over DC will be the same ratio as AB over AC. So we get lots of proportionalities with these triangles. All right, so here we know that this QS is an angle bisector because these are both marked congruent to each other. So we need to find PS and SR. We've got some algebra to do here because they're giving us X. So we know that, let's see, that X minus 2 over X plus 5 will be equal to 32 over 40. That's how we would set that up. And then we would have to solve this by cross products. So you'll take 40 times x minus 2, and use parentheses, equals 32 times parentheses x plus 5. Now you have to use the distributive property next. So 40x minus 80 equals 32x plus 160. Now we need to get our x's together, so I will subtract 32x from both sides. Minus 32x, and that gives us 8x. And we'll add 80 to both sides, which gives us 240. Then divide both sides by 8, and you get x is equal to 30. Now that's not what they asked us for. They didn't say what is x. They said find PS and SR. So then you have to take what you got, which was 30, plug it in, and you get 28 for this one. And you plug it into the x plus 5, and you get 35 for this length. And then you're all done. Okay, so here's another example using the same theorem. So we know that this is an angle bisector because both of those angles are marked congruent. So we can set up a proportion that this piece, the 4.5, over, now this looks weird, over y over 2 is equal to 8 over y minus 2. Now it looks weird, but that's okay because we're going to do cross products, right? So after we do the cross products, it won't look so strange anymore. We'll have 8 times, here, let me write it out how we have it. We'd have 8 times y over 2. Well, that's the same as 8y divided by 2, but that equals 4y. So when you multiply these two things, you just get 4y. And then on the other side, you'd have 4.5 times y minus 2. And they already did the distributive property and got that that would be 4.5y minus 4.5 times 2 is 9. So now we've got, let me erase this part here. Now we've got to get our y's together. So we'll subtract 4.5y from both sides, which leaves us with a negative 0.5y equals negative 9. Then divide both sides by negative 0.5. And you can check that on your calculator, but you should get y equals a positive 18. Now again, that's not what they ask you to find. If y is 18, we still have to put that back to find AC. Where's AC? This side. So 18 minus 2 equals 16. And then we also have to find side DC, so that means 18 over 2. We should get 9 for that side. All right, so that's about it. This should not be too difficult an assignment as long as you make sure you are setting up your proportions correctly. Go back to the theorems and double check that you are setting these up correctly so that you are not making a mistake on that. And then just do cross products, make sure to use distributive property if needed, do your algebra correctly, and that's about it. Have a great day, and please let me know if you have any questions on this assignment. Thank you.